Hello, welcome to Anybody Can Learn. Today we will learn types of gradient descent. Recall that gradient descent is an algorithm that helps us to find the best weight for our machine learning model. It updates the weight to reduce the prediction error, and the update formula is W new is equal to W old minus eta multiplied by gradient, where W new is a new weight and W old is old weight and eta is the learning rate. Gradient is direction of maximum increase of the loss. Now imagine that calculate the gradient using 100 million samples. This will take a long time and it is a very slow. Since the scientists developed the different version of the gradient descent to solve this problem. The three main types of the gradient descent are batch gradient descent (BGD), stochastic gradient descent (SGD), and mini batch gradient descent (MBGD). Batch gradient descent. Batch gradient descent uses all training samples to calculate the gradient. It calculates the gradient before updating the weight. For example, if there are 1000 training samples, batch gradient descent uses all 1000 samples before updating the weight. So it uses all 1000 samples, calculate the gradient and then update the weight. Stochastic gradient descent (SGD). SGD uses only one randomly selected training sample to update the weight. For example, in the iteration process, at iteration 1, SGD uses may randomly use a sample 3. Only sample 3 is used to update the weight. At iteration 2, it may choose another sample, that is sample number 1. Again, only sample 1 is used. Thus, the weight changes after every random sample. Why does the weight keep changing? During stochastic gradient descent, different random samples produces different updates. Notice that weights fluctuate because each update is based on different random sample. For example, suppose the initial weight, that is W superscript 0, is 2, and after iteration 1 the weight become 2.28. After iteration 2 weight become 3.4. After iteration 3 weight update to 3.0. After iteration 4 weight update to 3.6, and after iteration 5 the weight update to 3.3. So what is a capital T? A symbol capital T represents total number of iterations. In these examples we have 5 updates, we have 5 iterations. So if T is equal to 5, the algorithm performs 5 updates: W1, W2, W3, W4, W5. Formula for the final weight SGD is weight final is equal to 1 upon T multiplied by summation of Wi, where I ranges from 1 to capital T. Let's see the example. Suppose we have the 5 iterations and the weight are: for iteration 1 weight is 2, for iteration 2 weight is 4, iteration 3 weight is 6, and iteration 4 weight is 8, and for iteration 5 weight is 10. So add all the weights, that is 2 plus 4 plus 6 plus 8 plus 10. So this will sum to 30. Now divide the total iteration weight with total iteration. So we did 5 iteration. So 30 divided by 5 is equal to 6. So final weight is 6. Mini batch gradient descent (MBGD). Mini batch gradient descent uses a small group, that is mini batch, of training sample to compute the gradient. It comprises both batch gradient descent and stochastic gradient descent. Suppose the dataset has 1000 samples. We choose a mini batch size of 100. We continue until all samples have been used. So first mini batch sample contain the samples from 1 to 100. Then it calculates the gradient and then weight is updated. Then that weight is used for mini batch of 2, which is the samples from 101 to 200. Again gradient is calculated and weight is updated. So let us summarize it. Batch gradient descent uses all samples before the update. Stochastic gradient descent uses only one randomly selected samples at a time. Mini batch gradient descent uses a small batch called as a mini batch. Thank you.